Question 7, we have Hannah doing a training session. During this session, her heart rate, h of x, is this cubic function. For the first 8 minutes, Hannah does a number of exercises and then work out her heart rate 4 minutes. So that's h of 4. 2 by 4 cubed, just calculator use, check it twice. Minus 28.5 by 4 squared plus 105 by 4 plus 70. Her heart rate after 4 minutes is giving me 162 beats per minute. H prime x, just differentiate, you can do it straight away. 3 by 2, you know the rules here, otherwise you wouldn't be watching the video. 6x squared minus 228, 56, 57x plus 105 is the differentiated h of x, h prime x. Find h prime 2 and explain what this means in the context of Hannah's heart rate. Well, h prime 2 will be in relation to her beats per minute changing. H prime 2, 6 by 2 squared minus 57 by 2 plus 105. 6 4 is 24 and 105, 129 minus 114 is 15. So in the context of the question, her heart rate is changing at a rate of 15 beats per minute. You can write that out in English maybe too. And you've got the explanation there. The graph below shows y is equal to h of x between 0 and 8. Find the least value and the greatest value of h of x between 0 and 8. So the min and max points. Here's the max. Here's the local min. Here's actually the lowest point, and we asked for the lowest. The lowest is going to be when x is 0, it looks like. We get the other 2 points as well, just show them just in case. So let's find out what these are. When x is 0, we have our function. What was our constant? 70. H of 0 is equal to 70, so we can put that in. And then we'll solve the other one. So that's the min according to the graph. Anyway, we'll just check that the other one is definitely, if the graph is not drawn to scale, who knows, it could be down here. So solve to get the local max and min, h prime x equal to 0. We'll just go back up and look at the equation again. Remind ourselves, 6x squared. It doesn't factorize. I'm going to use the quadratic formula. Don't think it factorizes. I might give it one more go. Quadratic formula. If you can't see it straight away, it's just as quick. Could I actually divide 3 into it? Will that help me? 2x squared minus 19x plus 35. This, I didn't see factorization the first time. Let's see. 2x by x. 7 5s are 35. 14 and 5 is 19. Yeah, this works for us. So we have two values. We have x is equal to 5 over 2. Or x is equal to 7. So this is when x is 7. This is when x is 5 over 2. I'll just move this guy, 2.5 here. And 0. So let's just check 7 and 2.5. So just go back up to the top here. So just put h of 2.5 and h of 7 into a calculator. I'm not going to write both equations out here, but you could just delete into a calculator and then go back and change it. H of 2.5 is giving me 185.63. High heart rate. H of 7 is giving me 94.5. We got 70 actually as the lower one, so that's going to be correct. So just fill those values in. What way do they want it? Find the least and greatest. So the least is, that wasn't 70, that was 70 beats per minute. BPM. And we got when x is equal to 2.5. The BPM was at a max. That max was 185.63 or 186 maybe if you want to. Oh, it says the graph above, which is to scale. So there was actually, they told us there in the question, it was to scale. BPM. Next part of this question. How long after the start of the session is Hannah's heart rate decreasing most quickly within the first 8 minutes? So the answer in minutes and seconds. So this is h prime prime x. When is h prime prime x equal to 0? I'm messing this up. So what do we have? We had 6x squared minus 57x plus 105 was equal to h prime x. H double prime x is equal to 12x minus 57. I left the x didn't appear. When is this equal to 0? 12x is equal to 57. So x is equal to 57 over 12, which is 4.75. Is that 3/4 exactly? 4.75. It's 9 over 12. It is, yeah. 4.75 in minutes and seconds. 3/4 of a. So it's 4 minutes 45 seconds. For part E. Part F. Bruno, Karen, and Marta, they all start the training session at the same time. For the first 8 minutes, Bruno's heart rate, B of x, is 15 beats per minute more than Hannah's. Use this information to write B prime x in terms of h prime x. Okay, well, we have h prime x. We have 6x squared minus 57x plus 105. And that's B prime x. Sorry, h prime x. B prime x, well, let's look at B of x is going to be Hannah's one, plus 15. So your 2x cubed minus 28.5x squared plus 105x plus 70 was her one. So we're just going to add 15 onto this. So it's going to make the 70 85. So if we differentiate it, we're going to get the same answer. So B prime x in terms of h prime x, well, B prime x is equal to h prime x. I don't think they're looking for anything else here. Part 2 of F. For the first 8 minutes, Karen's heart rate is 10% less. And use this information to write k prime x in terms of h prime x. Well, k times h prime x, k of x is going to be equal to 10% less, so it's going to be 90% of 0.9 of the function 2x cubed minus 28.5x squared plus 105x plus 70. That's heart rate will always be 10% less. That's 90% of her function. So do they want us to multiply this out, or do they want us to just write it in simple terms? It's in terms of h prime x. So k prime x, the constant 0.9 can stay there, and if we differentiate this guy, it's just going to be h prime x as well. It's doing the same again. So k prime x is equal to 90% of h prime x. That's what they're looking for here. And then Marta does each exercise for a longer time than Hannah, between 0 and 10 for x. M of x is equal to x has been replaced by 0.8x. So instead of having x, we're going to have to replace these x's with 0.8x. And that's going to give us the cubic function. That's our answer. So m of x is equal to 2, 7x with 0.8x to be cubed. Just a lot of calculator work here. 0.8x to be squared plus 105 by 0.8x and then plus 70. So typing these into a calculator, 0.8 cubed times 2, 1.024x cubed minus 18.24x squared plus that's just 21 less than 105. 84x plus 70 is going to be the function m of x. And that concludes question 7.